I sent it.
Okay. Is there just one picture attached or more than one?
One.
Okay. You sent it to that email address? Yeah, there it is. All right, so we're doing absolute value functions. Is that what your test is on, or all of this?
This is just a day of review.
Okay. Let me just look at your answers here. These are all your answers, right?
Yeah, these are all my answers.
Okay. Do you want me to review some of them? Let me look here.
I know I didn't get the... Oops, I didn't get the bottom part of the sheet.
Well, let's see whether we need it or not. We may take up all of our time on the top part only.
Yeah.
I don't know yet. Let me look at it. So they're saying, how do you know if f of x, which is equal to a absolute value of that plus k, how do I know if that's a vertical stretch or a vertical shrink of the function? They call it f of x, but it really isn't good to call them both f of x. You see why? They're not both f of x. One is a different function than the other. If that is the parent function, well, how do I know if f of x is a shrink or a stretch of the parent function? That's the question. What's it based on?
You would know by... well, for one thing, if you...
There's only one letter that matters in this one. Right.
A.
It's a stretch if a is what?
Positive.
No, greater than 1.
Oh yeah, great. Sorry.
Stretch if a is greater than 1. It's a shrink if what?
It's less than 1.
Not just less than 1. If a was minus 3, that would not be a shrink. It would be between 0 and 1. So if a is greater than 0 or less than 1, in other words, it's got to be in that interval between 0 and 1. It's not just less than 1, because big negative numbers are stretches. Okay, the only thing that's going to represent a shrink is if a is between 0 and 1. Actually, to be more specific, it's a between minus 1 and 1. In other words, if a was minus 1/2, that'd be a shrink. If a was minus 2, that'd be a stretch. But anything that a is between minus 1 and 1 is going to be a shrink. Anything, in fact, I didn't actually give you the correct answer here. I'm close, but I'm not exactly close. For it to be a stretch, merely the absolute value of a has to be greater than 1. And then I could actually say that the absolute value of a has to be greater than 0 and less than 1 for it to be a shrink. Okay? But if a stretch, as long as the absolute value of a is greater than 1. In other words, if a is minus 5, that is a stretch. And the absolute value of minus 5 is 5, which is greater than 1. Therefore, it's a stretch. So that you don't need so many words in your answer as much as this information right here. You don't really have to explain anything. You merely have to know what letter it is we're concerned with at looking at in order to figure out whether it's a stretch or a shrink. And it's all about A. It's not based on H. It's not based on K. It depends on what A is. And it's not just, I was incorrect when I said A has to be greater than 1. It really is the absolute value of A, because I don't care. In other words, A could be 3, which is a stretch, but minus 3 is a stretch also.
Mm-hmm.
Okay, cool. Let's look at the next one here. So, well, let me go back just so you can maybe correct your paper here, because the answer you've given here really is not really anywhere close.
Yeah.
You multiply on the y-axis outside the parentheses by a negative. I understand what you're saying. In other words, when you take the function and you multiply it by a number, that is going to either be a vertical stretch or shrink, but they're asking what makes it a stretch, what makes it a shrink. And the information I have in the box, which you don't need that part, but if you say a stretch is when the absolute value of A is greater than 1, a shrink is when the absolute value of A is between 0 and 1.
Sorry, we didn't really go over this very much.
It's okay.
We went over it for like...
I'm glad you sent this page to me so that we could fix some of this stuff. Okay, describe 3 different types of transformations of the graph of an absolute value function. Well, here's the absolute value function. Okay. And that graph's like that with its vertex at the origin. Give me 3 things I could do as transformations.
1 second.
Give me one at a time.
My computer is loading and it's kind of really old, so it kind of just went to a black screen, so...
That's not good. Oh, you're not
Yeah,
on the same computer as Bolton either, are you?
No, he's on a newer one because I got this one like a while ago and he just got his like a couple... Okay, I'm back again.
Okay, cool. So tell me one at a time what 3 things you could do that would represent transformations of this function here.
I can't see your screen, but I think it would be, you could reflect it.
Across which axis? In other words,
Can't see it, so I'm just gonna get...
That's okay. You understand what I'm saying. If you have a piece of paper, well, we got to get you back to seeing my screen. Let's figure out why you can't see my screen. Your computer is frozen.
No, it's not frozen. It's just lagging and... Oh,
We can't do online sessions if you can't see my screen.
Yeah, I know.
I mean, they're impossible to do.
I know.
So either you need to get on to Bolton's computer for the last 15 minutes of this. Is that an option, or is he using it?
I think he's using it.
Well, get a piece of paper and pencil in front of you.
Okay, I will.
want to make you the presenter. I just got asked, can I make you the presenter? I can, but it wouldn't do any good.
Yes, no, sorry. Sorry, I accidentally clicked that.
Okay. Let me know when you can see my screen. Or get out a pencil and paper and write some stuff down on it.
I'm getting on a piece of paper and pencil.
Write down y equals absolute value of x.
Okay.
Now, tell me what 3 things you could do that would, any of them, be a different type transformation. What's one?
You could reflect it across the y-axis.
How do I do that?
By putting a different variable on the outside of the absolute value.
No.
Not a variable, but
the sign is what you're talking about. In other words, reflections are only accomplished with negative signs. If I put a negative sign right there, you can't see. If I put a negative sign in front of the absolute value, that's a reflection over the x-axis. It's a vertical reflection.
Yeah.
If I,
Oh, wait, sorry.
if I put a
Yeah.
negative sign in front of the x inside the absolute value, that's what represents a reflection over the y-axis. You with me?
Yeah, you could find then, you could transform it or
Tell me some other
move it.
stuff you could do. Let's not stop at 3. Let's tell me
You could stretch or shrink it.
how. And tell me vertically or horizontally, because those apply both ways.
That's by doing it, something on the
Yeah,
outside.
vertically.
Well, a vertical would be on the outside of the parentheses, and it would be multiplying.
And it would be a number greater than what?
It had to be number greater than 1 for...
Okay. So if I had a 2 in front of the absolute value, that would be a vertical stretch.
Uh-huh.
Okay, so that's one other thing we could do. How would we do a vertical shift?
Adding or subtracting a number.
So if I add to the original function plus 3 outside the absolute value sign.
It'd be a vertical shift 3 to the right.
Vertical,
3 up.
It's always vertical if the addition is outside the function.
Yeah.
If the change is inside the function, then it's horizontal.
I thought you said outside. I
did, because I said, how do you do a vertical shift? Okay, how do you do a horizontal shift? Give me an example of a horizontal shift for this function.
Addition or subtract, or
Give me
y
an answer.
equals...
Since I can't really tell what you're... In other words, if the parent function is absolute value of x, give me a horizontal shift answer.
Absolute value of x minus 3.
Yeah, that would be a horizontal shift which way?
3 to the right.
Good. Okay, so we've talked about 2 different reflections. We've talked about 2 different shifts, a vertical shift and a horizontal shift. And we've talked about a stretch factor. That's 5 things. There's only one last thing to be done, and that's a horizontal stretch or shrink. How do I do a horizontal stretch?
Horizontal stretch would be a greater number between -1 and 1, and that would have to be inside the parentheses.
Very inside the absolute value. Mark.
Oh yeah, well, absolute value. Or
in other words, y equals absolute value of 1/2 x would be a horizontal stretch. How would I, okay, and that's a horizontal shrink would be what? Give me an example of a horizontal shrink.
A horizontal shrink would be y equals, and then an absolute, y equals an absolute value of x.
An example.
Of x, 0.5.
No, that's the same as what we just did. In other words, the 1/2 x was a horizontal stretch. Remember that horizontally works opposite vertically. In other words, a vertical stretch is found by making a greater than 1. A horizontal stretch is found by making a between 0 and 1. But a horizontal shrink is found by making a greater than 1. So an example of a horizontal shrink would be y equal absolute value of 3x. In other words, the a is inside, making it horizontal, and it's a number greater than 1, making it a shrink.
Oh.
Okay, so what's the difference? Tell me the difference between y equal absolute value of 3x, write that down, and then y equal 3 times the absolute value of x. What's the difference between those two? What's the first one?
1 second. First one is a horizontal shrink.
And the second one?
A vertical stretch.
Correct.
Wait, yeah.
Yeah, they work opposite. In other words, one is a shrink if the number is greater than 1. The other is a stretch if the number is greater than 1. Okay, let me look at some of these others here. Describe the transformation. Okay, I think we can do this without you seeing my page. So if the parent function, f of x, is equal to absolute value of x, that's the original function, then tell me what's going on when I have p of x equal 1/3 absolute value of x.
It's a sorry, I'm kind of sick. It's going to be a vertical shrink by a factor of 1/3.
Very good. Change your paper because your paper says vertical stretch.
Yeah.
Okay. And number 4 on your paper. Are you looking at your paper also?
I'm looking at paper and correcting.
Good. Okay. So I don't really need to write anything. We can just talk about these. What is number 4?
J of x equals 3 and then absolute value of x.
When I say what is number 4, I mean what is the...
Oh, it's a vertical stretch by a factor of 3.
Okay, number 5.
It is going to be a vertical stretch by a factor of 5.
Plus what else is going on there? First of all, your paper says shrink.
Yeah, because it would be a stretch.
It's a stretch. But what's the minus sign mean?
It by a factor of -5.
Remember? No. You can't stretch something by a factor of -5. The negative, whenever you see a negative sign adjustment, it's a reflection. It's either a reflection over the x-axis, which is vertical, or it's a reflection over the y-axis, which is horizontal. So what is this?
It's a reflection over the y-axis.
No. Outside the function that makes it vertical. Remember, everything outside the function is vertical. Everything inside the absolute value, any changes going on?
Yeah, but y-axis is vertical. Y-axis is vertical.
Flip something over the y-axis, you're doing a horizontal flip. If you flip something over the x-axis, you're doing a vertical flip. You see why?
Yeah.
Okay. In other words, when you vertically flip something, if you take the palm of your hand and you move it across the x-axis, you're doing a vertical flip. So that's helpful because there's 6 transformations. 3 of them are vertical, 3 of them are horizontal. And they all fit this definition that everything vertical is outside the function, everything horizontal is inside the function. Okay, Number 6, what's going on?
It would be a
Start with the negatives.
a flip over the y.
No.
Vertical.
That negative sign is outside the function, right?
A vertical flip.
It's a vertical flip. But which axis is that? In other words, your teacher may not know what you mean when you say a vertical flip. I've kind of made that up because it goes with all the other vertical adjustments.
Y-axis.
Nope. Now here I need you to really see my paper because it's all I got to do is draw yourself a grid, a y-axis and an x-axis.
Yeah.
And draw anything you like in the first quadrant and flip it over the x-axis. That's a vertical flip. That's
so it would be a flip over the x-axis.
Yes, that's a vertical flip. A horizontal flip is a flip over the y-axis. don't misunderstand. Just because the y-axis is vertical doesn't mean a vertical flip is over the y-axis. It's when you flip that object, are you going left to right or are you going up and down? Well, if you flip something over the x-axis, you're going up and down, right?
Yeah.
That's a vertical flip. And it's nice and consistent with all the other vertical stuff. In other words, all vertical stuff is outside the function, all horizontal stuff is inside the function. But you have to remember that a vertical flip is a flip over the x-axis, and you have to describe it that way. You can't just say a vertical flip. He's not going to accept that. But if you say a flip over the x-axis, he will accept that. So number 6 starts with a flip over the x-axis. What else is going on? What's the 3/2 mean?
It means it is a... Oh yeah, it means it is also a vertical shrink.
No.
By a factor.
Stretch.
But
I'm not sure how to get you to memorize this, because the a is outside the function, right?
Yeah.
And it's greater than 1.
Yeah.
That makes it a vertical stretch.
But it's
the opposite on horizontal. I agree. But you have to remember which one is which. You can't remember they're opposite one another. You got to remember that when you're doing a vertical, numbers greater than a are stretches, numbers greater than 1 are stretches, numbers between 0 and 1 are shrinks when you're doing vertical stuff. And then is all you have to remember is a horizontal is the opposite of that. So if number 6 said minus absolute value of 3/2 x, where the 3/2 is inside the function,
yeah,
that's a horizontal shrink. But if the 3/2 is outside the function, it's a vertical stretch. And I don't know of a good way to get you to memorize that, but you got to memorize that in order for you to be able to distinguish. You can't just know they're opposite. You got to know that when vertical stretches, a is greater than 1. Okay, let's look at number 7. What's going on with numbers? Ooh, you know what? I have a 5:30 session I've got to go to. But this was good. I'm glad you sent me this. It was very necessary we go over this. It's clear that you're a little confused on some of it, but hopefully we've straightened you out on all of it. I think we have. In other words, the most important thing on you can't see my screen. Man, that's hard to tutor math when you cannot see my screen. I just can't hardly do it. Okay.
It will be fixed by next Wednesday.
If your computer's not working, maybe you can ask Bolton to borrow his for this half-hour session. We don't want to deal with this again. But I will talk to you next week, Logan.
Okay, bye.
All right, bye-bye.